Okay, here's some help with tonight's homework 10-5 practice. On this homework, we're trying to find the probability of both independent and dependent events. I'm going to do number 6 first. Number 6 describes an experiment rolling a fair number cube. So the numbers are 1, 2, 3, 4, 5, and 6, and tossing a fair coin. So on number 6, it asks us to find the probability of getting a 2 or 3 on the number cube, and then heads on the dime. So these are independent events because what we flip on the dime will be independent of what happens when we roll the number cube. So we learned in class today that the probability of two independent events occurring, probability of A and B occurring, equals the probability of A occurring times the probability of B occurring. So the probability of getting a 2 or 3 on that number cube would be, there's 6 possible outcomes on the number cube, 1, 2, 3, 4, 5, and 6, and we have 2 favorable outcomes. So that's 2 out of 6. And if we divide by 2 to simplify that fraction, we get 1 out of 3, probability of 1/3. Probability of flipping heads on the dime would equal 1/2 because we have 1 favorable outcome, flipping heads, and 2 possible outcomes, flipping heads or tails. So the probability of both of those events occurring, getting a 2 or 3 on the dice, and then flipping heads on the dime, would equal 1/3 times 1/2, and top times top, bottom times bottom, we get 1 times 1 is 1, 3 times 2 is 6, so 1/6 or 1 out of 6. All of the bottom problems from 7 to 15 describe this scenario. I'm going to do number 14, but it describes this scenario where we have a box containing 3 red marbles, 6 blue marbles, and a white marble. So I'm going to draw that box. I've got 1, 2, 3 red marbles, 2, 3, 4, 5, 6 blue, and 1 white. And we're drawing a marble at random, one at a time. We're not replacing them, and we're finding the probability of different outcomes. So if we're not replacing the marbles, on the first time we pull the marble, we can figure out the probability of that, but then for each pull after that, it depends on the first one because we have fewer marbles in the box and fewer of whichever color we pulled on the first one. So these are dependent events. Probability of A and B equals probability of A times the probability of B after A. After A occurred, the situation changes. We have fewer marbles in the box. So number 14 asks us the probability of pulling a white marble, and then a blue, and then a blue. So we have to figure out the probability of each one of these events. Probability of pulling a white marble, that's easy enough because we have 1 white marble out of 10 marbles total, so that's 1/10. The probability of pulling a blue marble after we've pulled the white marble would be, now we have 6 blue marbles out of 9 total marbles because we have 1 less marble in the box. The probability of pulling another blue marble, assuming we pulled that blue marble, would be 5 now out of 8. And the probability of all 3 of these things happening would be equal to all of these fractions multiplied together, 1/10 times 6/9 times 5/8. Doing top times top, bottom times bottom, we get 1 times 6 times 5. 6 times 5 is 30. And all these bottom numbers multiplied together, we get 10 times 9 is 90, times 8 is 720. So we have 30 over 720. Right away I know I can divide by 10 to simplify because both those numbers end in a 0, so I get 3 over 72. And I know 72 is divisible by 3 because 7 plus 2 equals 9. So simplifying again by dividing by 3, I get 1 over 24. So the probability of pulling a white marble and a blue marble and a blue marble without replacement would be 1 out of 24. Okay, I know this homework's pretty tough, but just give it your best shot and follow the examples and the equations we learned in class. And I'll see you in the morning.